So you probably remember everything that we talked about in the previous video from your signals class. So let's get into practicing again, and let's find the Fourier transform of a time domain signal. So let's find the Fourier transform of e to the minus at multiplied by ut, which is a step function. So let's use the definition to find the Fourier transform. So first, let's just plug in our time domain signal into GT, like this. Then let's change the integral limits from 0 to infinity, because we know that because we're multiplying by a step function, the signal is going to be basically multiplied by 1 from 0 to infinity, and is going to be equal to 0 when it is less than 0. So we can change the limits of this integral from 0 to infinity, and then we can remove ut from the integral. Once we've done that, it's going to look like this. All right, so now that we have this simplification done, let's combine the two exponents by adding them together. Then let's perform the integral, and we'll evaluate it from 0 to infinity. And we will replace t with 0 and infinity, like this. And now we're going to need to evaluate each of these expressions. Well, if we look at the first expression, because we're evaluating at infinity, we definitely need to make sure that this is actually going to work. So if we look at it for just a moment, we can see that a must be greater than 0 if we want to be able to evaluate that first part of the expression. So we're going to assume that whatever constant a that we have in e to the minus at, we're going to assume that that's greater than 0 in this case. And if we do that, we can see that the e to the minus infinity will evaluate as equal to 0, and e to the 0 evaluate as being equal to 1, which is going to give us this as our frequency spectra. So the Fourier transform of e to the minus at ut is going to be 1 over a plus j 2 pi f.